my name is Vidya. I work at Tableau Software, and I'm delighted to give a talk here about what are the trends with natural language in the domain of visual analysis. And a lot of people, when they think about natural language, they often think about certain types of applications, such as a chatbot. But I really want to impress and explore various other applications where natural language has proven to be a very useful piece of technology. All right, so a little background about myself. I've been at Tableau for a little over 7 years. I'm currently a principal research scientist, and I work in Tableau research. I have a background in natural language and computer graphics, and I've been working on applying those two fields in the space of information visualization. And I'm actually, I'm from the Midwest, so I got my PhD from Northwestern. And yeah, so I've kind of toyed between working in research and engineering over the past 7 years. And before that, I was at Nokia Research as well. So before we go into natural language, I wanted to kind of introduce the notion of semantics. So language and meaning is rather an abstract notion, and semantics is a way to formalize that concept. And it also helps think about models and language understanding in computers to make sense of information. And so all of this comes under the domain of natural language. We've all pretty much toyed with natural language technology in our daily lives by using Siri or Alexa, or even using meeting invites where Google is smart enough to parse the contents of your email and surface a meeting reminder or to confirm a subscription and so forth. Or if you go out to Google and you want to get like an instant currency conversion, Google will recognize the intent in your search query and provide a currency exchange widget. A more advanced capability of natural language is IBM Watson, where a computer was designed to mimic a human chess player in order to compete. So being able to understand higher level business logic and being able to map that into specific actions is sort of the North Star of natural language. So as part of this talk, I've organized it into various application areas. So I'm going to start off with data encodings and transformations along the lines of taking natural language and facilitating question and answering type interfaces, and then using the semantics of intent and content that needs to be searched to support semantic search. And then looking at how natural language can be used to generate text and summaries of one's data, all the way to things that are a little farther out, such as chatbots and smart assistant type interactions. So I'm going to start out with data encodings and transformations. And let's go through a particular example. So this is a bar chart that is visualizing produce. Say someone is interested in looking at the cost of various produce in their farm. And if you were to load it into an analytical tool like Tableau, without any notion of the semantics of the data, it will assign a default color palette. So in this case, broccoli is assigned blue, carrots is assigned brown, and so forth. And so there's not a semantic mapping between a color and what the actual contents of the data is about. So by using natural language and understanding the semantics and what broccoli represents, for example, those color palettes can become more semantically resonant, and all of a sudden, your brain doesn't really have to try mapping the disconnect between the color and the object and can actually parse and comprehend the chart a lot more easily. And this was a paper that we published a few years ago at the Visualization Conference, and you're more than welcome to peruse through that paper if you want to hear more details. Another example is addressing the problem that charts are inherently abstract. So this is a Sagan plot of body to brain mass of various animals. So if you're looking at this chart, your eye is trying to discern the patterns in the chart by following the dots and the arrows and the text. But if those text labels are replaced by icons that represent those animals, the patterns all of a sudden become more useful and easy to comprehend, because you're not trying to map something that is not semantically tied to the underlying data. So the area of natural language is by understanding a little bit of the semantics of the underlying data, can we provide useful encodings or useful representations? So this is another example. Say I've imported a data set into a visual analytics tool, and my dates are all parsed as strings. So these are all birthdays, and you see the first table on the left, they're all strings. And the system needs to understand, okay, how do I parse this into a date? And for those of you who have worked with dates, we know that dates can come in all sorts of patterns. In the US, we start off with, the month, and then followed by the date. But in places like England or India, for example, you start off with the date and then the month. So if I look at 1307, that could be January 3rd, 2007, or March 1st, 2007. And so that's ambiguous. But what a natural language algorithm can do is look at the entire context of the column, and then you see 4/15/08 as the second entry, and you can't have a month which is numbered as 15. So the system says, okay, so this is month first, date, and then year, and it will convert it into dates, as you can see in the second table, and make an intelligent data transformation. So what I'd like to impress here is by understanding the context and the semantics, and being able to disambiguate strings that are ambiguous by looking at the other context, an intelligent system can provide reasonable defaults for data transformations. So along those lines, building upon that, another place where there's a lot of ambiguity in how data needs to be interpreted for visual analysis is around location data. So say I have some sales data and I need to be represented in a map, and I have this little data blurb here. So you see various cities, Houston, San Antonio, Dallas, Austin, Paris, along with its relevant sales information. Now, a naive system would take those places, assuming that there's no geocoding information, and it would map Paris to France. But this is not expected, because the context of the majority of the data is in Texas. And perhaps there's additional context by the locale of the data as well. So the way a smart system that incorporates natural language, it would look at the holistic context of the data and then say, well, there's actually a Paris in Texas. So let me mark that as the most plausible Paris location along with its sales information. Along these lines, there are other applications where natural language can play a role, and that is around smarter sorting. So for those of you who are familiar taking surveys, you often see questions containing these Likert scales where it expects a response from strongly disagree to strongly agree. And when you import that data into a visual analytics tool, you don't want it to be sorted by alphabetical order, but there needs to be a sort based on the semantics of the data, and also map an appropriate color palette to this. So in this case, by understanding that the data belongs to a Likert scale, a smarter sort can be organized along with a divergent color palette where red gets mapped to the most negative semantics and blue, dark blue, maps to the most positive one. So another important aspect of data transformation for visual analysis is joining multiple tables. And traditionally, a lot of joins have been equi-joins. So basically, the tool will look at a column in one table and find, an identical column in another table. But quite often, these tables may not be identical. So in this case, the table in blue has country codes, US, CN, JP, etc., and the table in green has the actual names. So we need to be able to compute a mapping between the country and its relevant country code in order to do a smart semantic join. And you can imagine this getting much more nuanced. Say you have currency in US dollars and currency in British pounds, you might want to do a translation from one currency type to the other based on the exchange rate of the timestamp of the data. So these are some additional places where we're exploring how natural language can be used to do these smart, non-obvious data transformations. And similar to combining multiple tables, quite often people in their ETL process will take a single column and try to split it up. Now, you could take a single column and say, I want to parse these by the space between the first and last name. But for certain types of known domains like names and places, natural language could recognize that these are names based on external survey information or an employee database and be able to decipher what is the first name and what is the last name, and also rename those split columns appropriately as well. So that kind of ends the first part of data encodings and transformations. And so now let's explore how natural language can be used for supporting more fact-finding search where people ask questions about their data. So extending the location semantics example that I showed you, this is a particular feature that was implemented in Tableau where, say, you have a map of your data and you want to search for a particular data value in your data set. And if I type in Paris, I want the system to recognize what is in the context of my data and surface Paris, Texas, because my data is of the US and not of the world, and demote Paris, France, which is more prominent than Paris, Texas. I mean, no offense to anyone who's listening from Texas, but traditional geospatial algorithms tend to rank these more prominent places higher. But in this space of visual analysis, we really need to look at the context of the data to figure out what the ranking of the results or suggestions should be. So we started off with map search, and that was implemented in Tableau. And then in Tableau Research, we started looking at ways of extending that to support more of an analytical conversation with users. So, I live in California, so I keep thinking about earthquakes and say I'm looking at earthquake data and I want to just type in find large earthquakes near California, and you'll see a highlighted result here showing earthquakes of a certain magnitude of 5 and greater highlighted in this map. And I want to be able to ask follow-up questions. So I don't want to retype, show me large earthquakes near Texas, but just like having a conversation with another human, I want to just build on that and say, how about near Texas? And so we implemented a system that recognizes language pragmatics. And language pragmatics is basically understanding the context of what was said previously and applying whatever is relevant to a subsequent utterance in your conversation. So the system's like, oh, okay, this user is still referring to large earthquakes, but is actually changing the location to Texas. And as we started looking at kind of basic question and answering with data, we also started exploring deeper analytical concepts using natural language. So being able to ask questions like, show me the trends for next month, and being able to surface a forecasting model that would forecast the data for the next consecutive months and show that to you. So that research prototype resulted in an actual natural language feature in Tableau called Ask Data. And there are similar types of natural language interfaces for other analytics tools like Power BI, ThoughtSpot. But all these players are really looking at ways in which data interaction can be made more accessible to the audience by allowing people to just ask their questions in simple natural language form, and the system can understand that and produce a visualization response. So with a system like Ask Data, we support various types of analytical questions, like what's the sum of price for each country, or a filter question, wineries in France, which is a geospatial filter, or kind of showing the top 5 wineries, or sorting. So these are all these basic analytical functions that can be asked through natural language without the user having to really understand the complexities of the interface. And I'm not saying that natural language can completely replace everything that is shown in these tools, but it is a way for making data interaction more accessible. And so even though we have supported natural language and we have a feature out, the problem space is still vast, and there's a lot of open problems that we're still thinking of. So being able to understand the intent of a user and being able to surface appropriate visualization responses. So let me walk you through an example in terms of what I mean here. So say I'm looking at Titanic data and a user asks, show me children aboard who survived. And the system will return a bar chart showing whether children were on board and how many of them survived and not survived. I can ask a follow-up question, break this down by sex and age, which means I am referring to the previous bar chart, and the system says, okay, I'm just going to add sex and age. And since sex is only female and male in this example or in this data set, it will break it down by color and add age as a grouping to the bar chart. So you could still see the same bar chart, but it is broken down further. But then I ask another follow-up question. What was a correlation between age, fare, and survival? And all of a sudden, the system has to make a decision of whether to represent that intent in the current bar chart or completely replace it and show, say, a highlight table. And in this case, the highlight table is a more appropriate visualization response to show the user's intent compared to a bar chart. So the nuances and complexities of supporting a conversation between a human and a computer is not only understanding the linguistic intent through these utterances that are expressed in natural language, but also understanding the intent of the visualization and which visualization will best match what the user is asking. So while we want to support questions about data, quite often people will ask questions that requires additional semantics that needs to be augmented with the data. So say I'm looking at a data set of house prices and house characteristics, maybe like a Zillow or a Redfin data set. And I ask a question, show me house prices. And right now, it's a very easy thing to solve. Prices can be fuzzy matched to price, and the system knows what to show. But then it gets a little bit more complicated. I might ask, show me expensive house prices. And now all of a sudden, the system needs to figure out what does expensive mean, because there's really no field in the data set called expensive. But augmenting the data set, say with a thesaurus or a dictionary, the system knows that expensive alludes to price based on the definition for expensive and can provide a higher bound or a higher limit for price that can map to expensive. But users talk in different ways. Instead of price, I might say show me house cost. So the system needs to have access to a thesaurus so it could get synonyms and say, okay, cost is a synonym of price, and I can understand what you're saying. And then it gets a little bit more complicated. Show me large houses. What does that mean? Does large mean area? Does it mean, square feet? So in this case, it's much more nuanced. So the system needs to understand what large means and what area means, and being able to map the two to provide a sensible analytical response to the user. But when we're having conversation, this is where humans are still much more skilled than a computer. I might just say, show me square feet of houses, and I might abbreviate it. And all of a sudden the system's like, I don't know what to do because I don't understand square feet because it's abbreviated. So this is sort of active research where machine learning could be a tool for a system to learn these new concepts and abbreviations or domain-specific concepts over time as the users continue to interact with the system. So I'm just going to explain quickly how this is done through machine learning. I'm not going to go into too much detail, but there is a corpus called Google Ngrams, which contains a digitized set of books and articles on the internet. And those books often contain words like sqft. So the system can access such a huge corpus and figure out how similar the word sqft is to the other words in the data set. And in this example, you see that the semantic similarity between sqft and beds is small enough, and so it could interpret that appropriately. So we have found that there is a large trained corpus of information that's available that is often used to augment these natural language techniques to perform even better. In addition to asking questions about data, when people are presented a dashboard, for example, it's quite common for them to ask about properties in the dashboard or visualization. So I'm looking at housing data here. This is a dashboard around Seattle neighborhoods, and I can ask a question: what's the spike in that blue line? So the system needs to understand that spike maps to a line chart because there are 3 visualizations here, and then map the word blue to an appropriate color, which is townhouse, and show a result. And that is, those are kind of more nuanced algorithms that need to combine techniques from the visual space as well as the linguistic space to come up with sensible responses. So here are some other examples where external knowledge is often used to provide a greater sense of understanding by the system. So there are corpuses like Wolfram Alpha, which has a lot of information on units and measurement, as well as Wikipedia. Wikipedia is particularly good at temporal information like events and dates. So being able to ask questions like highest and lowest temperatures in Fahrenheit over fall, being able to leverage Wolfram Alpha, for example, recognize this as a unit and convert it to Celsius if the data is in Celsius, and being able to take the term fall and map it to the appropriate time period. Say, maybe I'm in New Zealand, so Southern Hemisphere fall is different from Northern Hemisphere, and showing a sensible result. So the complexities of language provides all sorts of new challenges for natural language algorithms to behave appropriately. A lot of people we've found ask, what or why questions. So if I'm looking at pound versus dollar and I ask, what is the drop in July 2016? Where this person actually means, why is there a drop? So being able to go out to search engines and try to get more information And that information can translated into an annotation and an explanation. That was Brexit, so that's why there was a sharp fall. So these why questions are particularly interesting and challenging, and quite often systems need external domain information to provide sensible explanations. So along the search space, autocompletion is another tool that a lot of people are familiar with. If you go to a search engine now, you will find autocompletion suggestions helping you complete a query, and it's there in various types of user interfaces. So we have been exploring how autocompletion can be used in the context of natural language when people are exploring their data. So we built a system called Sneak Peek, which will be presented on Friday at a conference called WIST. And I will present a little video of how this system works in terms of providing visual autocompletion and suggestions as people are interacting with their data. And so with that, I will play a video. Here is the Sneak Peek interface showing a dashboard of coronavirus cases around the world. The user starts out by typing "show me cases in." Map and calendar widgets appear to autocomplete the partial query. Notice that the data frequency of the values is color encoded in each of the widgets. The user picks the US and the dashboard gets updated. The user then types on showing a calendar widget with a data preview for the US, which is in the context of the query. She finds that there is a high incidence of cases in April and picks a date. She now wants to see only deaths and picks the text autocompletion to complete her query. She resets the context by typing "start over" and types "cases more than 300 between" to show a date range slider. She then picks a range. She proceeds to add a country. Notice that only countries with cases greater than 300 are shown in the map widget. She decides to pick Canada. Now, as she's typing, she switches over to the text view in the map widget to check out the various cities for each country. Okay, so that's just a little demo of how the system works. Here is the sneak. Oops. Okay, there we go. Okay, so the next piece that I'm going to quickly go over is using natural language to explore deeper analytical questions with additional content. So Tableau Public is a portal where people can actually search for visualizations and workbooks that others have authored. And if I type in Golden State Warrior wins over the years, the search will just return any sort of content that contains the terms Golden State Warrior wins over the years. But the user actually doesn't mean that. He or she would like to take, find workbooks containing Golden State Warriors, but return perhaps time data showing how the team did over the past few seasons. And this is kind of a place where we need to understand additional semantics in the query to provide reasonable results. And this has a lot of ramifications for search engine optimization. So if I go to Google and I type in Golden State Warrior wins over the years, we want to return sensible results that recognizes that over the years has a different concept than Golden State Warrior wins by showing time series views at the top of the search results. So from searching for information, another place where natural language can be used is for generating text and summaries. And automatic captioning for images, because I view images and visualizations to be somewhat similar, is something that the computer vision community has worked on for quite some time. And it's gotten better. And that's why you see that Google image search has also gotten better, because it not only looks at documents that refer to images, but it can also find objects in the images and return appropriate results. But it's still a hard problem, as you can see in this highlighted image below. So what we are exploring are ways in which we can understand and provide more explanations in the forms of text for these visualizations. And what you see most commonly are captions that describe what's in the chart, as you can see highlighted here. But we also want to look at ways in which captions can be surfaced during an analytical conversation, where I'm looking at this dashboard of disease outbreaks around the world, and I want to ask, show me the orange spike, and the system will respond with a pithy annotation highlighting that point. Other places where natural language is used is providing narratives or summaries of the data, and they can often be quite verbose. And these are useful for generating reports or for accessibility, if for visually impaired folks, and so forth. So the last one that I wanted to just quickly give you a teaser on is how natural language can be used to explore chatbots and smart assistants for interacting with data. And so we're currently looking at how we can integrate data exploration through Alexa or Google Home or your watch, or even something like the Echo Show. And I'll briefly play a video, and that will be close to the end of my talk.
Hi there. Ask a question about the wine's data and I'll try to help.
Show me the wines by location.
The most expensive wineries are located in the United States.
Show me the most expensive varieties.
The most expensive variety is the Cabernet Sauvignon.
Show me the cheapest ones.
The cheapest variety is the Malbec Syrah.
Thanks, Tableau chatbot.
Goodbye and enjoy TC.
So TC is our Tableau conference. And so this was a demo that we showcased at the conference to get users' feedback. So there's this interesting challenge of not only presenting the visualization results, but figuring out what would be an appropriate audio response that the system should give to the user. It can't be a full summary, so it needs to be something short and succinct. And so it's a constant active research area that we're exploring.
Hi there.
Oop. Okay, there we go. So this is the end of my talk. I'd like to really thank you for attending and participating. This is a link to the Tableau research website, which has access to all sorts of papers that I discussed in this talk. So feel free to peruse through that website. And if you would like to reach me later and have any questions or comments, that's my email, and I'd love to hear from you. And at this, I'm happy to take any questions. Yeah, and that's it. Thank you.
Thank you. Great talk. And that demo was really interesting. And I can't think of a better use case than pricing wine. So good choice.
Yes. Thank you.
I don't see any questions in the chat right now. So I'll say to the audience, thanks for joining. If you have questions, go ahead and post those into the chat box. Speak now or forever hold your peace. Okay, well, I don't see any questions. Okay. So we can probably go ahead and wrap. So thanks again, everyone. Great talk. Really interesting.
Thanks, Nikki, for facilitating it.
Absolutely.
Bye.
Enjoy the rest of the show, everyone. Thanks.